Welcome back to the deep dive. Today, we're really diving into something that's, well, it's reshaping global security pretty dramatically.
It really is. We're talking military robotics,
Yeah.
AI drones,
Yeah.
and this huge, complex struggle to keep humans in control.
Yeah.
Meaningful human control.
Yeah, exactly. And this isn't just theory anymore, is it? It's right here, now. Law, policy, psychology, cutting-edge tech, all mashed together.
It's arguably the most critical tech conversation happening right now.
Yeah.
And the sources we've pulled together today, I mean, they cover everything. Military history, those big ethical moments like Project Maven.
Oh yeah, that was huge.
And even, real-time analysis from conflicts like Ukraine. It shows just how fast things are moving.
So our mission here, for you listening, is to give you a real shortcut to understanding what's truly at stake. When we start shifting humans away from making those life or death decisions.
Right. It's profound.
Okay, so let's set the scene. The sources paint this picture, kind of a glimpse into the near future. Imagine it's, say, 2030, a standard patrol.
Right.
You've got a human sergeant out front leading, but the squad, it's not just people. There's this quiet four-legged robot, like a pack mule, but robotic.
Right, a quadruped. Carrying gear.
Exactly. Carrying the heavy stuff, ammo, supplies, navigating the rough ground on its own. And overhead, not a loud chopper,
Something stealthier.
a swarm of small drones mapping everything in real time, high-dev visuals stitched together.
And AI processing it all.
Yes. An AI system analyzes that data, suggests better routes, maybe flags hate signatures a human might miss, points out potential threats. But, and this is key, that Sergeant still has the final say, the override. The decision to engage is still human.
For now.
Right. But the machine's done, like 90% of the thinking work leading up to it.
That image, it's really powerful because it nails where we are right now. That scene sits right at the convergence of these two, ancient human desires.
Okay, what are they?
Well, first, there's that super old urge to make tools that extend our bodies, amplify our senses.
Right.
From a spear to a telescope to a drone camera.
Makes sense. Extending our reach.
And the second impulse,
Yeah.
it's often the stronger one. The drive to push danger away from human life. To win without casualties.
Right. Keep our people safe.
Robotics, remote systems, they seem to do both at once. Better capability, less risk. But, and this is the core problem, while they fulfill those old desires, they create totally new risks. Moral ones, political ones, systemic ones.
Risks we're only just starting to really get our heads around.
Exactly.
So we have this huge tension, amazing potential versus, well, unprecedented danger.
Yeah.
So today we're going to trace how we got to this 2030 patrol scene. We'll look at the psychological effects, the institutional shifts, and really dig into why this tech is causing such a massive global split.
Between those calling for bans and those who see full autonomy as basically inevitable.
Exactly. Let's get into it. Okay, so when we talk military robotics, it feels very cutting edge, but the basic idea, the impulse behind it, it's actually ancient, right? We're talking way before the 20th century.
That's such a crucial starting point, yeah. We think silicon chips, but the drive for self-operating things, it goes back centuries. If you trace the lineage of robots in that classical sense.
Like the old Greek myths.
Well, even documented stuff. First century CE hero of Alexandria, he wrote about complex clockwork automata. Think intricate machines for festivals, maybe religious displays.
Wow, okay. Not exactly war machines then.
No, not yet. But there were early concepts of machines following preset instructions, a kind of, deterministic autonomy. They showed humans could delegate tasks to mechanisms.
But just fancy props, really. When does it actually get militarized? When does that idea meet warfare?
It really kicks off with industrialization. Mechanized warfare in the 20th century. Tanks, planes, submarines, radio comms. These started putting distance between the soldier and the target.
But the human was still in the machine, usually.
Right, physically present. It wasn't until after World War II, really, that defense research started laying the academic groundwork for the kind of mobile sensing machine we think of today.
Okay, so Cold War era now. And robotics as an academic field is starting to mature.
Yeah, and a lot of that research was heavily funded by defense money. They wanted ways to operate in, hazardous zones, nuclear fallout areas, places humans couldn't go.
That funding must have been huge.
Transformative. And it led to the basis for modern unmanned systems, especially ones that could perceive and react. Think 1960s Stanford Research Institute. And the specific example we have to talk about is Shaky the robot.
Shaky. Okay, I've heard of Shaky. Wasn't super impressive physically, right?
No, not fast or strong, but it was a huge leap conceptually.
Why? What did it do?
Shaky was the first mobile robot that could, reason about its environment. It had sensors, cameras, touch sensors, and basic planning software.
So it could see something and decide what to do.
Exactly. It demonstrated that core loop.
Yeah.
Sense the world, plan an action based on what it sensed like, figuring out how to go around a box, and then execute that action.
Okay. Sense, plan, act.
Before Shaky, robots were mostly just repetitive industrial arms. After Shaky, you could see the potential for, intelligent machines interacting with the physical world.
And that potential leads straight to DARPA, right? The Defense Advanced Research Projects Agency. They started making some big bets from the 80s into the 2000s.
Precisely. DARPA's Strategic Computing Initiative poured billions into AI research, and a key part of that was autonomous land vehicles. This is the line that leads not just to self-driving cars eventually, but also those high-mobility legged robots.
The ones designed to go where soldiers go.
Yeah, the ones meant to support infantry in really rough terrain.
We're talking about those kind of creepy four-legged robots.
Yeah.
The ones that look like metal dogs or mule.
That's the ones. Boston Dynamics Big Dog, and then later the LS3, the Legged Squad Support System, sometimes called Alpha Dog.
Right. And what was their job supposed to be?
Pure logistics, really. Robotic mules. The idea was they'd follow soldiers across difficult ground, carrying hundreds of pounds of gear, water, batteries, ammo.
So the soldiers wouldn't have to hump all that weight.
Exactly. Let them focus on the mission, not the load.
Yeah.
And this R&D. It really pushed robotics out of the clean lab and into the messy real world. The challenge wasn't just walking, it was balance, uneven ground, sensing load shifts.
Reacting to the unexpected.
Totally. Meanwhile, while this is happening on the ground, the air domain is going through its own massive shift.
Yeah.
The drone revolution, starting in the 90s.
Okay, yeah, drones.
This was huge.
Yeah.
Remotely piloted aerial vehicles, RPVs, they started out as basically spy planes. High altitude, long endurance eyes in the sky. Pure surveillance.
But then they strapped weapons onto them.
That was the game changer. Adding weapon, hardpoints, precision guidance, they turned into precision strike platforms.
Yeah.
The Predator, and especially its successor, the Reaper MQ-9, that changed conflict forever.
Because now you have this persistent eye in the sky that can also strike instantly.
Right. And the pilot could be sitting in an air-conditioned trailer thousands of miles away, maybe in Nevada, like you said.
Completely changing the idea of risk and distance.
And creating this new strategic edge. Persistent presence without putting your own pilots directly in harm's way. But what's really fascinating now is the democratization. Okay, the Reaper is a super sophisticated multi-million-dollar thing, but the basic tech, it's trickled down.
You mean like the small quadcopters you can buy online?
Exactly. Small, cheap quadcopters, often adapted from photography drones, have spread aerial surveillance and even attack capabilities everywhere. And that, in turn, opened the door for these low-cost but effective loitering munitions.
Kamikaze drones.
Right. You suddenly don't need air superiority or a massive budget to have an effective air weapon.
That's a huge shift. Makes advanced capabilities accessible to way more actors.
It absolutely is. It lets smaller states, even non-state groups, achieve effects that used to be only for major powers. That's a massive destabilizer, potentially.
So we hit the 2010s, and things really speed up. Machine learning explodes onto the scene.
Right. And this changes the game for autonomy. It moves beyond just simple navigation. Now systems can handle complex perception, identification.
Understanding what they're seeing.
Pretty much. Advances in deep learning, especially computer vision, meant machines could now do tasks that used to need intense human focus, like analyzing tons of video feeds way faster than a person could.
Finding vehicles, troop movements.
Yeah, flagging anomalies. This enabled automation in logistics, sure, but also, much more controversially, in targeting functions.
And that leads us straight into that big ethics blow-up everyone heard about, Project Maven.
Yep, Project Maven, U.S. Department of Defense, around 2017. The goal was to use commercial AI, the kind developed by big tech companies, to analyze the insane amount of drone footage the military collects.
Just drowning in data, basically.
Totally, years worth of video, daily. So AI was supposed to help detect and classify things in that footage.
But the sources say there was a massive backlash inside the tech companies involved. Why Maven? What made it such a flashpoint?
Because it felt like the moment where general-purpose AI stuff engineers built from apps or image search, was being directly plugged into the military's kill chain.
Okay, crossing the line.
That's how many employees saw it. Protests, resignations. Tech workers drew a moral line in the sand. They argued their algorithms shouldn't be used to help kill people.
And the companies felt the pressure.
Absolutely. The fear of losing top AI talent, the brand damage, it forced several big players to publicly rethink their defense contracts and actually put out formal AI ethics policies saying they wouldn't work on weapon systems.
So it wasn't just moral arguments, it was also about talent retention, a practical business concern.
Exactly. It showed that employee activism could actually put real constraints on these corporate-state partnerships. It's become a key part of how this tech gets governed, especially when official regulation lags behind.
And this internal corporate fight was happening alongside a bigger global pushback from civil society, right? Focusing on autonomous weapons.
Yeah, that mobilization has been critical. It's centered on banning or at least severely limiting lethal autonomous weapon systems law Ws. You saw those big open letters back around 2015, 2016.
From scientists and researchers.
Yeah, organizations like the Future of Life Institute got over 1,000 leading scientists, AI experts, even Nobel laureates to sign on.
What was their main argument? Why the push for a ban?
The core worry was handing over the final kill decision to a machine, no matter how smart it seems. They felt it was an unacceptable moral risk, maybe even an existential one.
Too dangerous, could destabilize everything.
That was the fear, that these weapons would lower the cost of war, speed things up dangerously, and cross a moral line we could never uncross. This whole debate really solidified the idea of meaningful human control as the crucial ethical standard we need to aim for.
Keep a human in the loop.
Essentially, yes. But while all these debates are happening,
Yeah.
the tech isn't waiting. It's already defining battlefields. Ukraine is the prime example right now, a grim sort of laboratory.
Yeah, what's striking there is just the scale of drone use and the integration. It's not just the fancy military drones, it's the massive creative use of cheap commercial drones.
The off-the-shelf kind.
Exactly. Adapted for spying, for spotting artillery targets, even for dropping small bombs. And we've seen certain specific systems get a lot of attention.
We definitely have. Early on, the Turkish Bayraktar TB2, that showed how a relatively low-cost drone could effectively hunt and kill really expensive Russian equipment like air defense systems.
Punching above its weight, basically.
Totally. And then on the other side, you have Russia using huge numbers of those Iranian Shahed kamikaze drones, loitering munitions.
Used in those big waves of attacks.
Right, saturation attacks.
Yeah.
The idea isn't precision so much as overwhelming the defenses.
What's the big takeaway from seeing these systems used so heavily in Ukraine?
I think it's their relatively low cost combined with high effectiveness. It's fundamentally changing how forces project power. UAS can operate persistently, strike deep behind lines, hit critical infrastructure.
Making everything feel vulnerable?
Pretty much. It extends vulnerability way beyond the front lines, right into civilian power grids and deep military bases. That changes everything.
The tech is incredible, unsettling even. But let's pivot to the people, the operators. What does it actually do to someone to operate these powerful remote weapons, sitting far away, looking at a screen?
Yeah, the psychology there is really complex and kind of counterintuitive. It's often called the emotional distance paradox.
Okay, unpack that.
Well, on the surface, the operator is safe, physically removed from the noise, the chaos, the immediate danger of the battlefield. So you'd think less stress, right?
Yeah.
Reduces the immediate combat trauma.
And it does, in that immediate sense.
Right.
But the sources suggest there's a delayed, different kind of harm.
Exactly. That physical distance, combined with the very analytical screen-based nature of the job, tracking targets, clicking icons, it can actually lead to serious psychological issues later on.
Like PTSD.
Yes, but it's often distinct. We need to differentiate traditional PTSD, which usually stems from a threat to yourself, from something called moral injury.
Moral injury. Okay, what's that?
It's the deep psychological distress that comes from doing something, or seeing something done, that violates your own core moral code. For drone operators, it can be the delayed realization of their direct role in killing, but without the shared risk or the fog of war you get on the ground.
So it's trauma from what you did, not what happened to you.
That's a great way to put it. And that video game interface, it kind of makes it worse.
How so?
Well, the operator has to be incredibly focused, analytical, identify the target, check coordinates, follow procedures. But the interface itself strips away the messy physical reality of the strike zone. It feels clean, detached.
Which makes it easier in the moment, maybe, but harder to process later?
That seems to be the case. It increases dissociation, this feeling of disconnection, which can make dealing with the lethal consequences much more difficult down the line.
Okay, now let's flip the perspective. What about the people on the other end? Civilians, non-combatants living under the constant threat of these drones, always potentially being watched, potentially targeted.
Oh, the psychological impact there is devastating. The sources talk about chronic anxiety, hypervigilance, this constant state of being on edge.
Like you can never relax.
Exactly. And of a profound sense of learned helplessness. The feeling that these machines are omnipresent, that constant buzz overhead, maybe, or just the idea that something unseen can watch and strike anytime, day or night, it just shreds any feeling of safety.
How does that change how people live day to day?
It forces huge changes in behavior. People might stop trusting neighbors because who knows who's being watched. Basic things like going to the market, gathering in public, even traveling. People change routines to avoid being seen, to avoid being out in the open.
So it isolates people too, erodes the community.
Absolutely. It frays the social fabric.
Okay, let's zoom out again to the institutions. How is adopting all this robotics and AI actually changing military organizations themselves?
It's causing a pretty radical internal shift in power dynamics. When a military goes hard on these advanced systems, it has to reorganize itself around the flow of data.
Data becomes king.
Essentially, decision-making power, operational command, it all starts to centralize around sensor fusion, around the ISR pipelines, intelligence, surveillance, reconnaissance. Speed of processing that data becomes the ultimate advantage.
But if everything centers on data and sensors, does that create risks? Like losing touch with the ground truth, maybe creating groupthink around the data?
That's precisely the danger the sources highlight. Prioritizing data speed creates institutional winners. The tech units, the cyber teams, the AI analysts, they gain influence.
And who loses out?
Traditional roles, maybe? Infantry, human intelligence gathering, roles based on physical presence and hands-on experience can get marginalized. Doctrine might shift too heavily towards remote, data-driven decisions, potentially relying on incomplete or misinterpreted sensor data.
We saw with Project Maven how civil society pushed back. How does that broader activism continue to shape what these powerful military and corporate institutions do?
Activism plays a crucial role in demanding accountability and transparency, often moving faster than government regulation. Ethics groups, NGOs, researchers, they mobilize to demand things like audit trails for AI decisions, explainable AI, more openness about deployment rules.
How effective is that, really?
It can be surprisingly effective. By using global media, highlighting ethical concerns, and sometimes tapping into those corporate fears about losing talent, they applied real pressure. It shows that public norms and ethical debates do still matter in shaping how military tech evolves.
Okay, last point in this section, collective mindsets. How is society thinking about all this? Are we getting used to remote killing? Is it becoming normalized, or is there still a strong taboo against it?
We're seeing a real tug of war between those two forces. The normalization risk is definitely real. Drones are getting cheaper, more common even in civilian life deliveries, filming, inspections.
So we just get used to seeing them everywhere.
Right. And that can subtly lower the barrier to accepting their use for surveillance, and then maybe for lethal force. When police use drones, when drone strikes are reported clinically in the news, it risks making remote violence seem, well, normal.
But there's a pushback, the taboo.
Absolutely. The taboo counterpush is strong. It comes from deep moral revulsion. Academics, human rights groups, NGOs, and significantly religious leaders, the Vatican, for instance, stressing human dignity, are actively campaigning.
What's their goal?
To preserve that fundamental requirement for human judgment in lethal decisions. They want to establish a clear international norm, maybe even a treaty, declaring fully autonomous killing unacceptable. Those ongoing debates at the UN about laws, that's the main arena for this moral resistance, trying to build a global taboo before the tech becomes completely widespread.
Okay, let's talk geopolitics. These unmanned systems, they're clearly changing how nations interact, how they use force.
Oh, massively. They're huge force multipliers. A country can project power, intervene somewhere far away, strike back at threats, all with much lower immediate risk to its own soldiers or pilots.
Because you don't have pilots to get shot down or captured.
Exactly. That lowers the political cost of using force significantly. It makes it easier for a government to decide to take military action, which, can subtly, or maybe not so subtly, lower the threshold for starting conflicts in the first place.
And if it's easier for big powers, the risk of this tech spreading everywhere, proliferation, must be huge.
That's the critical danger zone. Proliferation just lowers the entry barrier for everyone. If the tech is cheap, If it's based on commercial stuff you can adapt, then smaller states, non-state actors, proxy groups,
Yeah.
they can suddenly get their hands on high-impact weapons.
Like we saw with the Iranian drones being used.
Precisely. That shows how relatively cheap, mass-produced tech can let actors bypass traditional military superiority, get around sanctions, and still achieve significant strategic effects. It democratizes destruction, in a way.
Okay, we need to take a breath here and tackle some of the myths. Separate the science fiction from the reality on the ground.
Good idea. Myth number 1, the biggest one probably. Robots are going to immediately replace all human soldiers.
Right, the Terminator scenario.
Yeah, not happening anytime soon. The reality is, autonomy complements human roles. It takes over the dull, dirty, dangerous tasks. Logistics, long-duration surveillance, bomb disposal, maybe.
But not making complex battlefield decisions on its own.
Not yet, and maybe never entirely. Full replacement is held back by ethics, by law, by reliability issues, and frankly, by political will. No major power seems ready to hand over ultimate command authority, especially when things go wrong and someone has to be held accountable.
Okay, myth 2.
It's about the word autonomy itself. People hear autonomous weapon and think Skynet, sentient AI,
General artificial intelligence.
consciousness.
Right, and that's just not what's being deployed. The systems out there now are narrow AI. They follow rules, or they use machine learning for specific constrained tasks, like identifying a tank or following a flight path.
Exactly. They operate within tightly defined parameters. They don't have general judgment, common sense, critical thinking, or anything remotely like moral reasoning. They're incredibly sophisticated tools, yes, but still just tools.
Which brings us smack into the really hard controversies, the stuff keeping lawyers and policymakers awake at night, starting with the biggest one, the accountability gap.
Ah, yes. This is the absolute core legal and moral headache of autonomous warfare. When an autonomous system makes a mistake, myth identifies a target, hits civilians, who was responsible.
Under traditional laws of armed conflict, it's usually the commander or the operator, right? Someone with intent and control.
Exactly. Accountability hinges on human intent and control. But autonomy just blows that wide open.
How so?
It creates this jurisdictional nightmare. Is the fault with the programmer who wrote the dodgy object recognition code, the company that sold it? The commander who set the rules of engagement too loosely? The operator who was maybe just monitoring a screen and didn't intervene fast enough?
The blame gets diffused everywhere.
Across corporations, military chains of command, maybe even across borders. It makes finding fault, prosecuting someone, or even getting compensation for victims incredibly difficult. And this erosion of clear responsibility, it's one of the strongest arguments against allowing full lethal autonomy.
We touched on this earlier, but let's dig into that controversy. Does making war cheaper actually mean more war? Lowering the threshold?
The argument is pretty strong. Remote strikes, low human cost up front. It definitely reduces the political friction for a leader deciding to use force. It's easier to sell a drone strike politically than putting boots on the ground or risking manned aircraft.
So it incentivizes action over, say, diplomacy?
Potentially, yes. The counter-argument from some defense folks is that overwhelming remote capabilities might actually deter conflict. But even they usually admit that the lower immediate human cost makes intervention more tempting.
Okay, before we move to case studies, you mentioned something interesting earlier, how sometimes these brilliant advanced technologies fail for really simple, mundane reasons.
Yeah, this is a great reality check, often buried in the details. The sources point to the DARPA LS-3 program, that legged robot mule, AlphaDog.
Right, the technically amazing walking robot.
Technically brilliant, stable, could handle rough terrain, carry a heavy load. A marvel of engineering.
So why did they basically shelve the program?
Okay, get this. It was too noisy.
Noisy.
Yeah. The hydraulics, the motors needed to power those complex legs. They made this loud, constant whirring sound. Imagine you're an infantry squad trying to be stealthy on patrol.
And you've got this loud mechanical dog following you around.
Exactly. Completely ruins the point. Other mundane problems included maintenance difficulties in the field and just soldier acceptance. The troops found it kind of cumbersome and awkward to actually use in practice.
Wow. Millions in R&D, tripped up by noise and practicality. That's a lesson.
It really highlights that operational utility doesn't actually work for the soldiers in the field. And user acceptance are often bigger hurdles than the core technology itself. Other things that cause failures. Fragile supply chains for specialized parts, sensors getting jammed or confused in combat environments, electronics failing in dust or rain. The messy reality bites back.
Okay, let's zoom in on some specific examples now to see how these systems are actually changing things on the ground. First up, the Turkish Bayraktar TB2.
Ah, the TB2. It got really famous in conflicts like Libya, Nagorno-Karabakh, and especially early in the Ukraine war. It's a prime example of a relatively cost-effective drone, medium altitude, long endurance, or melee that had a huge impact.
Not the most advanced drone in the world technologically?
No, not necessarily, but its tactical effect was revolutionary for the countries using it.
How did it manage that? What made it so effective?
It offered persistent surveillance combined with precision strike capability, usually using laser-guided missiles. It could loiter at medium altitude, often just outside the range of many short-range air defenses.
So it could hunt effectively.
Very effectively. It proved highly successful at surgically taking out high-value targets like tanks, artillery, and crucially, those expensive air defense systems themselves. It allowed nations with moderate budgets to basically punch way above their weight.
Using the cheaper drone to kill the much more expensive enemy gear.
Exactly. A great example of how tactical innovation with available tech can really shift the balance.
Okay, now let's contrast that with the other big case study. The Iranian Shahed kamikaze drones, used extensively by Russia against Ukraine.
Right. The Shaheds represent a totally different strategy, but one that's also proving powerful. These are simple, mass-produced loitering munitions, sometimes called flying lawnmowers because of their distinctive engine sound.
Not very sophisticated individually.
No, they're relatively slow, not very stealthy, quite vulnerable on their own. But the key is they're used in mass, swarms of them.
What's the goal of sending them in large numbers like that?
It's about overwhelming the defenses. Saturation. The idea is to force the defender, Ukraine, in this case, to use up their limited and very expensive air defense missiles, shooting down these cheap incoming drones.
So it's an attritional strategy, draining the defender's resources.
Partly that, and partly targeting strategic infrastructure. They're often aimed at power grids, substations, communication hubs, things that cause maximum disruption to the economy and civilian morale.
So volume over precision, aimed at infrastructure.
Exactly. It shows the impact of high-volume, relatively cheap UAS on national vulnerability. And it also really highlights the importance of geopolitics and supply chains, how alliances allow states under sanctions to still field highly damaging capabilities.
The tech varies, the strategy varies, and the ethical and political views on this stuff vary wildly across the globe too, right?
Oh, absolutely. You see really clear differences based on political systems and culture. In Western democracies, the U.S., Europe, the debate is heavily focused on things like the law of armed conflict, LOAC, public accountability, ethics committees, tech worker activism.
Trying to put rules and oversight in place.
Right. Regulatory efforts like the EU's AI Act try to categorize risk and mandate human oversight for the dangerous stuff. Transparency is at least valued as a goal, even if it's not always perfectly achieved.
Okay, what about authoritarian states, where transparency isn't really a priority?
For authoritarian regimes, the focus is almost entirely on operational advantage and state control. They deploy surveillance tech, robotics, AI for domestic control, for regional influence, with very few public constraints.
So the risk of misuse is much higher.
Significantly higher, both internally against their own populations and potentially externally. And the lack of transparency makes it incredibly hard for the international community to monitor or verify anything. The main driver is effectiveness, not legal process or ethics.
And then there's the global south, lower-resourced countries.
For many of them, it's about leveraging cheap, commercial, off-the-shelf drone tech for asymmetric warfare. It gives them new capabilities, yes, but it often creates a dependence on foreign suppliers.
They don't have the industrial base to build their own advanced systems.
Usually not. So they end up being consumers, or maybe modifiers, of technology developed elsewhere, which can reinforce existing global inequalities and dependencies.
And finally, let's not forget the non-state actors, like religious groups, weighing in.
That's a really important voice. Religious perspectives, like statements from the Vatican, for example, often provide a strong moral framework. They consistently emphasize human dignity and the absolute moral necessity of keeping human judgment central to life and death decisions.
Adding moral weight to the calls for regulation.
Exactly. It adds significant authority to those international efforts pushing for treaties or strong UN protocols, reminding everyone that this isn't just a military or legal issue, but a fundamental question of human values.
Okay, we've covered a huge amount of ground. History, tech, ethics, geopolitics. Let's try to pull it together. What's the core consensus, if there is one, among experts looking at this? What's the main concept people are rallying around?
The absolute center of gravity in the expert debate, especially among AI researchers and ethicists, is this idea of meaningful human control, or MHC.
Right, we mentioned that earlier. It's the proposed compromise.
Exactly. It tries to find a middle ground. It accepts that AI and autonomy are useful, even necessary, for things like processing sensor data quickly, identifying threats the machine can help perceive. But MHC insists that a human must be the one to make the final, irreversible decision to use lethal force.
Sounds reasonable. But the devil's in the details, right? What does meaningful actually mean in practice?
That is the million-dollar question, and where it gets incredibly difficult. It's the policy nightmare. If an AI flags a target, and the human operator has, say, half a second to hit confirm or deny before the opportunity is lost, is that really meaningful control?
Or is it just a rubber stamp, a legal fiction?
That's the debate. How much time does the human need? What level of understanding of the situation, of the AI's reasoning, do they need? Can they actually interrupt the machine's process? Defining MHC in a way that's both ethically sound and operationally workable is the huge challenge.
Meanwhile, you have defense analysts pushing back, saying overly strict MHC could cripple effectiveness.
Right. They emphasize speed, efficiency, and importantly, the potential for autonomy to reduce casualties on their own side. They argue that in really fast-paced combat, humans might simply be too slow to react to threats, so some level of autonomy is essential.
Their argument rests on having strong legal guardrails in place.
Yes, they argue that technology can be managed with robust rules, audits, clear lines of responsibility, without sacrificing the operational edge that autonomy might provide. It's that fundamental clash: moral process versus operational outcome.
Beyond the mainstream military and ethics debate, are there other critical perspectives we need to consider, like critiques of the whole system?
Definitely. One important one is the surveillance capitalism critique.
Okay, what's that angle?
This perspective argues that AI weapons aren't just military tools developed in isolation. They're deeply tangled up with the commercial tech world data pipelines, cloud computing services, the business models of major tech corporations.
So military choices might be influenced by corporate interests.
That's the concern. Things like vendor lock-in, where a military becomes dependent on a specific company's proprietary AI systems or cloud platform. It means crucial aspects of military capability and even doctrine could be shaped by corporate incentives, potentially outside of normal public or democratic oversight.
Interesting. And what about the peace studies view? How does that frame the issue?
Peace study scholars often focus on how the diffusion of this technology changes violence patterns. They argue that cheap, easy-to-use drones tend to proliferate quickly, often fueling regional conflicts and disproportionately harming weaker states or civilian populations first.
Because it makes cross-border attacks easier and less risky for the attacker.
Exactly. It shifts conflict dynamics in ways that might favor escalation and destabilization rather than resolution.
So, given all these pressures and complexities, where are the big policy battles happening right now? What are the hotspots to watch?
Well, beyond the ongoing struggle to define MHC, two huge areas are proliferation and corporate access control.
Proliferation seems obvious, stopping this tech getting into the wrong hands.
Right. But it's incredibly hard. How do you control the export, not just of drone hardware, but of the sophisticated AI software, the models themselves, especially when much of it builds on open source research? Preventing non-state actors or rogue states from getting these capabilities is a massive challenge.
And the corporate access part.
That's about who builds, owns, and maintains the critical data infrastructure that these AI systems rely on, who controls the cloud platforms, who trains the algorithms. Control over the data stack is increasingly becoming control over future military capability. It's a huge strategic issue.
So, looking ahead, if you want to track how this develops, what are the main policy pathways or arenas to keep an eye on?
Three key areas, I'd say. First, the diplomatic efforts at the UN, specifically the Convention on Certain Conventional Weapons, CCW. That's where the push for an international treaty or binding protocol on law de Villos is happening. Will they reach consensus?
Okay, the UN treaty track. What else?
Second, technology governance measures within nations or alliances. Things like demanding mandatory audit trails for AI decisions, insisting on explainable AI systems that can articulate why they made a recommendation, and pushing for more transparency in military procurement processes.
So you can see who's building what and how it's supposed to work.
Right. And the third crucial area is tackling the dual-use problem head-on.
Meaning tech that can be used for good or bad.
Exactly. Policy needs to get much sharper at drawing lines. We want AI for good things: logistics support, medical evacuation robots, environmental monitoring, disaster relief. But regulations need to be really clear and firm about banning the autonomous application of lethal force without meaningful human review.
Preserve the benefits, prohibit the worst risks.
That's the tightrope walk. #outro.
Wow. Okay, this has been incredibly detailed and frankly pretty sobering. It's crystal clear that this whole conversation about military robots and AI, it's not really about the machines, it's about us. It's about human choice, human agency.
That really is the bottom line, isn't it? This isn't just tech specs. It's fundamentally reshaping how we as humans make life and death decisions. It's shifting power balances globally. It's even changing what normal life feels like when you're under constant surveillance or the threat of remote attack.
We're negotiating how much responsibility we keep for ourselves in the face of machines that seem incredibly efficient.
That's the core tension.
So for you listening, thinking about where this goes next, where should you be focusing your attention over the coming years?
I'd say keep a close eye on those international norm-setting efforts at the UN, especially how they grapple with defining meaningful human control in practice. That's critical. Also, watch the continued impact of cheap drone proliferation in smaller conflicts. That's often where the most disruptive and sometimes dangerous innovations emerge. Asymmetric warfare is a real testing ground.
Makes sense.
And finally, pay very close attention to where this intersects with human augmentation technologies. Things like advanced exoskeletons, maybe even neural interfaces connecting soldiers directly to systems. That line between the human operator and the intelligent machine is getting blurrier.
Yeah, that opens up a whole other set of ethical cans of worms. The pace of change is just relentless, and policy always seems to be scrambling to keep up.
It often is. Which means the choices being made right now about things like procurement standards, about algorithmic transparency, about repairability, about civilian oversight, these decisions are incredibly consequential. They're setting the path for the future character of conflict. Which leads us to that final provocative thought for you to mull over. It's really this. The choices we make today about transparency, about accountability, about keeping humans truly in the loop, will those choices ultimately guide these technologies towards reducing suffering, as proponents hope? Or will they inadvertently help institutionalize new, unaccountable forms of violence and pervasive surveillance on a global scale? That moral balancing act, that's the challenge. It's the high-stakes responsibility we all collectively have to grapple with.